Have you ever wondered what it would be like to teleport? It's a concept that has fascinated us for centuries, a staple of fantastical tales and science fiction narratives that continues to captivate our collective imagination. Think of Star Trek's iconic transporter or the magical apparition in Harry Potter. But what is teleportation really? In its simplest form, teleportation is the theoretical transfer of matter or energy from one point to another without having to traverse the physical space between them. Imagine stepping into a teleporter in New York and stepping out in Tokyo, all in the blink of an eye. No planes, no trains, no automobiles. Just you, disappearing from one location and reappearing in another almost instantaneously. This concept, while seemingly fantastical, is deeply rooted in our desire for convenience and speed. It's a dream of ultimate mobility, of limitless freedom. Imagine just vanishing from one place and appearing in another in an instant. But how would teleportation work in reality if it were possible? Let's ponder this intriguing question. The concept of teleportation, as we know it, is largely derived from the field of quantum mechanics, specifically the principles of quantum entanglement and quantum superposition. To comprehend this better, let's unpack these terms. Quantum entanglement is a phenomenon where two particles become inextricably linked, regardless of the distance separating them. It's like having a pair of dice, each on opposite ends of the universe. Roll one die here and its partner, light years away, will instantly reflect the same result. This is referred to as spooky action at a distance by some scientists. In the context of teleportation, this could theoretically enable the instantaneous transfer of information from one location to another. Now let's talk about quantum superposition. This principle suggests that a particle can exist in multiple states at once, but we can only observe one of those states at any given time. It's akin to having a coin spinning in the air. It's both heads and tails until it lands and we observe the result. In teleportation, quantum superposition could allow an object to be in two places at once. So, how does all of this translate to teleportation? Well, in theory, teleportation would involve scanning an object down to its smallest particles, transmitting this information to the destination, and reassembling the object. This process, known as quantum teleportation, has been achieved on a minuscule scale with particles of light called photons. However, it's important to note that these theories remain largely untested and speculative when applied to larger objects, like humans. Quantum mechanics is known for its uncertainty, and these principles are still at the forefront of scientific exploration. Teleportation, as we understand it today, hinges heavily on the principles of quantum mechanics. It's a fascinating field, filled with potential and mystery, and it's the foundation upon which our understanding of teleportation rests. As we continue to explore the quantum world, who knows what possibilities we might uncover. The concept of teleportation is exciting, but it's not without its challenges. Imagine being able to travel from New York to Tokyo in the blink of an eye. That's the promise of teleportation. But this futuristic mode of transportation comes with a host of challenges that make it, at least for now, the stuff of science fiction. First, let's talk about the Heisenberg uncertainty principle. This principle, which is a fundamental part of quantum mechanics, states that we cannot know both the position and momentum of a particle with absolute precision. This creates a significant hurdle for teleportation, as it would require us to know both of these things to successfully transport a person or object from one place to another. Now let's move on to the second challenge, the need for a receiving station. You see, teleportation isn't just about moving something from point A to point B, it's about reconstructing it at point B, and for that, you'd need a receiving station. Think of it as a very advanced 3D printer that can construct a person or object atom by atom. The technology to create such a station is currently far beyond our reach. And then there's the potential for catastrophic failure. The process of teleportation, as we understand it, would require the complete deconstruction and reconstruction of the object or person being teleported. If anything goes wrong during this process, the results could be disastrous. We're talking about the potential for a person to be reconstructed incorrectly, or not reconstructed at all. And finally, there's the issue of energy. Teleporting even a small object would require a staggering amount of energy. Some estimates suggest it would take more energy than is produced in the entire world in a year to teleport a single human being. These challenges make teleportation a difficult, if not impossible, task at our current level of understanding and technology. So, is teleportation purely the stuff of science fiction, or could it become a reality? Well, that's the million-dollar question, isn't it? Let's delve into the current state of research into teleportation to find out. Now, most of the teleportation we're familiar with comes straight out of Star Trek or Harry Potter, instantaneously popping from one spot to another. But the reality is far more complex and, dare we say, even more fascinating. In the scientific community, there's been significant progress in a field known as quantum teleportation. Now, don't let the term intimidate you. It's not about beaming people or objects across space. Instead, quantum teleportation deals with something much smaller and much more elusive: quantum information. Here's a simplified explanation. Imagine two particles that are entangled. This means they're connected in such a way that the state of one particle immediately affects the other, no matter how far apart they are. This instant connection is what scientists are exploring in quantum teleportation experiments. In these experiments, information about a particle's state is transferred or teleported to its entangled partner. This doesn't involve the physical movement of the particle itself, but rather the instantaneous transfer of information about its state. Now, you might be thinking, that's all well and good for tiny particles, but what about teleporting something larger, like a human? Well, therein lies the challenge. The human body is made up of an unimaginable number of particles, all in various states. Teleporting a human would require knowing the exact state of each of these particles, a feat which is currently beyond our technological capabilities. But don't be disheartened. The important takeaway here is that teleportation, at least at the quantum level, is not just a far-fetched fantasy. It's real, it's happening, and it's opening up a world of possibilities in the realm of quantum computing and communication. While we may not be teleporting humans anytime soon, the teleportation of information at the quantum level is already a reality. But what would the impact be if teleportation were possible? Let's dive right in and imagine a world where teleportation is as commonplace as taking a bus or hailing a taxi. Transport as we know it would be revolutionized. No more sitting in traffic, no more long-haul flights. The daily commute would be a thing of the past. You could have breakfast in Paris and be in New York for a business meeting in the blink of an eye. The world would become a much smaller place, bringing people together like never before. But with such a paradigm shift, new challenges would inevitably arise. The potential for misuse and the ethical implications are a Pandora's box just waiting to be opened. The possibility of teleporting into secure locations or private residences raises serious security concerns. Could criminals or terrorists exploit this technology for nefarious purposes? And how would we ensure privacy when anyone could, theoretically, pop into your living room unannounced? And then there's the question of the self. If teleportation works by deconstructing and reconstructing matter, would the person arriving at their destination be the same person who left? Or would they be an exact copy, a clone? These are profound philosophical questions that touch on the very nature of identity and consciousness. Furthermore, how would teleportation affect our economy? The transportation industry, from airlines to trucking companies, would face massive disruption, potentially leading to job losses on a grand scale. But at the same time, new industries and job opportunities could emerge, centered around this groundbreaking technology. The environmental implications could also be significant. The reduction in traditional travel could lead to a drastic decrease in carbon emissions, helping in the fight against climate change. But the energy requirements for teleportation could be astronomical. Where would this energy come from, and what would be the environmental cost? The implications of teleportation are as vast and varied as the concept itself. But one thing is clear: the world as we know it would be forever changed, for better or for worse. So, where does that leave us with teleportation? After exploring the fascination, understanding the mechanics, and discussing the challenges, we find ourselves standing on the brink of a new era. The current state of teleportation research is promising, with advances in quantum physics and nanotechnology hinting at a future where the impossible becomes possible. Yet, the road ahead is filled with hurdles. The sheer complexity of teleporting even the simplest of objects, not to mention a human being, is daunting. The ethical and societal implications are equally profound. Would we lose our sense of place? Would our identities become fluid, changing with every teleportation? But remember, every great invention was once deemed impossible. The airplane, the internet, even the humble light bulb. Teleportation may seem like a far-off dream, but so did these revolutionary ideas at one point. While teleportation remains largely in the realm of science fiction for now, who knows what the future might hold?